Okay, so experiment 3. So if I take that cathode ray tube and I have my slit and I have my prism, okay, I'm going to separate out the light from that cathode ray tube into individual colors. Okay, so if I look at hydrogen, hey, earlier spectra of hydrogen showed this red line, this blue-green line, and this violet line. There's actually 4 lines on hydrogen. We have better equipment now. That's the thing with science, is as we do more, our equipment gets better and more sensitive. And so sometimes we can detect things that we previously couldn't detect because our equipment wasn't sensitive enough. Okay, so there's certain wavelengths associated. So if you notice the larger wavelength over here with our less energetic red, the smaller wavelength over here with our more energetic violet. Okay, notice that the wavelengths are nanometers. Okay, remember a nanometer is 10 to the negative 9th meters. So these are really small. Okay, all right, so there's a drawing of the hydrogen spectra. Here's an actual picture of the hydrogen spectra, and you can see all 4 lines there. So there's 1, there's 2, there's 3, and then there's this really faint one over there for our 4th line. Okay, and up here in the corner, there's our cathode ray tube with the hydrogen gas in it. So again, next semester, 141, provided we're back on campus, you'll actually get a chance to do some of these cathode ray tube experiments and see some of these spectra. Now, if we do this for other elements, oh my goodness, look, we get individual spectra. Okay, so just like we all have unique fingerprints, every element has a unique line spectra. So this is sometimes called atomic fingerprinting. Okay. When you do your Labster activities this week, the atomic structure and isotopes activity will actually have you look at some stuff and see if you can figure out what elements made up a distant star. So this is how we can figure out what's around extrasolar planets or distant stars. Is all we have to do is train a telescope in those areas and we can get these line spectra. We don't actually have to send a probe. So if you've ever wondered, well, how do scientists know what's around an extrasolar planet? It's because of this atomic fingerprinting. We know the spectra for all the different elements. And so if we have a spectra from a distant planet or a distant star, we can compare that with our known and figure out what the unknown was made up of. Now, when I look at these, okay, I can't tell from the periodic table how many lines something is going to have. Okay, we only know the lines that stuff has by doing this experimentally. All right, and so what's happening to create these lines? Well, we're going to explore that in our next section when we talk about the Bohr model of the hydrogen atom.